Let's start. And today we will be doing the chapter of light. Doesn't matter if you have done this in school or not. Doesn't matter if you are in Sec 1 or Sec 2. It's still a secondary, lower secondary topic. Okay. Some schools may teach this topic in secondary 1. Some schools may take it to secondary 2, which means whether you are 13 or 14 years old, you are clever enough to learn this topic. That's why it's called lower secondary and it's put in one textbook. And we don't distinguish between Sec 1 and Sec 2. We call it lower secondary science. And that's why you are all here together. Okay. And to make matters easier, it's actually a chapter that's already been covered in primary school. So shouldn't be a problem. We just build on that knowledge from primary school. So we have learned the concept of light. We have learned the concept of reflection. We have seen the mirrors. But what else do we need to learn in secondary school? You probably need to take note of the type of images that form, for example, and some characteristics like words like upright or inverted or laterally inverted or real versus virtual or diminished versus enlarged. Diminished is actually becomes smaller, enlarged becomes bigger, but we have to use scientific terms and we always use diminish and enlarge. Okay, so these are the things that we're going to go through. And we're going to take 2 weeks to actually complete this. So seat belt, tighten, sit tight, and hopefully we get there by the end of this roller coaster ride. We probably need to do reflection today, and then next week we do refraction, and that's a little bit more difficult, which you didn't do in primary school. So today, reflection plus some characteristics of images and some convex concave mirrors, and we should be fine. But next week we go into reflection. Okay, now that you know how to press the yes and no button, reply. How many of you tried the homework I gave you? If you have like, oh, teacher, you mean there was homework? You can type. Or I don't know where to find the homework. You can type. Okay, I just want to see the responses, what you guys have been up to throughout this week, because I did give you some work, but it was different from the previous weeks because I did not give you the questions directly on the paper, but I told you to go to the 88Tuition website and access a particular lesson. So I don't know how many of you did it. So if you did or did not, you just have to say, yes, I did it, or no, I didn't, by clicking the yes or no button on your screen. Where is it? Click on participants. At the bottom of the screen, you will see a green button, yes, and a no. I just need you to participate to say, yes, I did this work before coming to class, or no, sorry, teacher, I didn't have any time to do this. I was actually trying to do all my homework on Monday before I go to school, which is the normal scenario in most homes. Everybody is doing their holiday homework on the last day. I know. Okay, good. Whether you did or not, doesn't matter. I'll give you some time to do the questions along with us in the classroom. Hopefully, we get to learn what we wanted to out of this lesson by 7 o'clock. Then we can check out of here and go have our dinner. Those of you had dinner already. Not good to have dinner too early, then you feel sleepy very early. You should have dinner after this. Or you should have dinner now before this if you intend to sleep by 8 o'clock. Okay, these are the rules of life where you should not shower immediately after eating. You should not be sleeping after eating immediately. At least 1 to 2 hours should be left before you start sleeping after eating. Okay, let's go. Reflection. This guy is seeing his reflection in water or on any shiny surface. So reflection is the first concept we will learn in the chapter of light. Okay. Let me just organize this. To play around with the pen and then pen bye-bye. Okay, reflection, bouncing off light. Shall we go to the next slide? Still giving me trouble. Sorry, guys. 1, 2, 3. 1, 2, 3. Come on, guys. Okay. Light that is reflected undergoes regular or irregular reflection. Okay, take note of regular or irregular. Now this is the problem that I'm facing. Okay, give me a second, because my slide is not cooperating with me. But you can still know what I'm talking about, but you have to absorb, like meditate. hang on. Okay. Yeah, I can write. You know what's giving me the problem? The pen. So maybe I will not write for something for a while. Okay, now let's go talk about the second. Light that is reflected undergoes either regular or irregular reflection, depending on the smoothness of the reflecting surface. Now, look at the word regular and irregular reflection here. I'm going to change that to another word. Is there another word that we can talk about for irregular reflection? Who knows? Can you type for me? Irregular reflection can be called by another name. What is it? Let's see who can respond. Unconstant? No. In terms of light. Starts with D. D-I. Okay, here, right? D-I-F-F-U-S. Yes, diffused. Okay, let's do diffused. There you go. Can you see? I changed the word irregular to diffuse. Thanks for your answers, Doreen, Jane, and Jerry. Okay, you are trying to find an equivalent word with English, but I was trying to find an equivalent word in science. Okay, so that's the difference. Okay, in science, usually we have particular terms to mean certain things. When you mean irregular reflection, is actually diffuse reflection. So you will see this coming across in your textbook, workbook, exams a lot. So when somebody says, oh, Jane saw a diffuse reflection on this surface. So what does it mean? What does diffuse mean? Okay, it means irregular. So what does it look like? Let's see. Okay, we'll see it in the slide. I'll show you what a diffuse reflection looks like in pictorial terms, right? For science, we need to look in pictorial terms. Okay, so this guy is standing in front of a mirror, and obviously you know what you look like in a mirror, right? All of you, even you can see on your screen right now, if your video is on, you can see that's like a mirror. It's taking the image of you and presenting it to you. But most of the time, when you raise your right hand, it looks like the left hand in the image. When you raise your left hand, it looks like the right hand in the image. So that is called laterally inverted. Okay, when something right becomes left, left becomes right, it's called laterally inverted. And images formed are the same size. You don't see a bigger version of you in a mirror or a smaller version of you in a mirror. Of course, it must be a plane mirror. If it's a different kind of mirror, if you tell me, sir, I saw myself very small in a different kind of mirror. Yeah, those mirrors are different because they are curved. They may be curved inward or outward. We call them convex or concave, which we'll also look at later. But plane mirrors, when it's called plane, you see the word here, plane, P-L-A-N-E, means flat. Okay, only two-dimensional. There's no three-dimension. So when it's plane mirror, then the object will be the same size, will be upright, will not be inverted. You do not see the leg and head change orientation. It will be the same, but only the left and right will change, and that will be laterally inverted. Okay, cool. So these are the characteristics that I just spoke about. What are the three? You need to be able to write this down whenever you're asked. What are the characteristics of the image formed in a plane mirror? Not just mirror. They won't just say mirror. They will say plane mirror. Why? Because just say mirror means you can have a question like, sure, then are you saying convex or concave or plane? Because convex and concave, the size will change. But here, the size won't change. So it will be same size, upright, laterally inverted, and virtual. This word virtual is also important, means cannot be captured on a screen versus real. Okay, the opposite of virtual is real. Real means can be captured on a screen. So, you know, when your teacher teaches and flashes you PowerPoints and then it's on the screen, that's real because you can actually see it on the screen. Whereas in the mirror, when you stand in front of the mirror, your image is not on the mirror, but right behind the mirror, somewhere where you can't actually touch it. It's behind. You can't put your hand through and find him or find your face because it's behind the mirror, like 5 meters behind if you're standing 5 meters. So the distance matters, right? Like you see in this picture below here, if you are standing in X1, if you're standing in X1 here, you're going to have an image that is in X2, exactly the same distance away. And therefore, you cannot have a real image. A real image will form on the screen itself. That's the difference between virtual and real, okay? So this is what we need to pick up for light on a plane mirror as compared to learning light in primary school. Okay, don't worry about copying any notes, or these notes will be available to you afterwards in the past lessons. You know, after this lesson is over, you can go back to the same website that you click join class and then you say, hey, I missed last week's class. So I go to past class and then I click past class, and what will happen? You'll have these PowerPoints and also the video of me talking. Whatever we talked about here, even if you took part in the class, your voice also will be in the recording, and we will put it up on the website, and the copy will actually lead you to the YouTube, so you can actually find it on YouTube as well. Okay. Now, this is how a ray of light. Okay, whenever we draw a light, actually light is composed of many rays, right? You look up. Can you see light in your room? Yes. Can you really see the ray? You can't, because they are made of millions and millions of rays. Millions of rays, but there's at least one ray, right? So 1, 2, 3, I can count. So if I just pick up one ray, then I can draw it just to show you how the physics of light works. When any ray comes down and bounces off any surface, like the mirror that is shown on the diagram here, it will bounce off. And if the surface is really smooth, like this mirror, then it will bounce off with equal angles, where I is equal to R. Now, how do you measure I? How do you measure R? The angle at which it comes down to the normal. Do you see a normal there? The normal is drawn 90 degrees, okay, perpendicular here. You see the normal here? I show you here with my dot. This normal is drawn 90 degrees perpendicular to the surface that the light is bouncing, which is the mirror. Okay, so that's clear. And then from there, you measure the eye. So you take a protractor, you put it down there, you measure the eye, your protractor says 35 degrees, then eye is 35 degrees. And light, having bounced on a smooth surface, bounce perfectly on another 35 degrees. So R is equal to 35 as well. This is where we say I equals to R. I stands for angle of incidence, and R stands for angle of refraction. All right. Images formed by reflection. Okay, so now we can identify the image which we summarized earlier, but there's a difference. What is the difference? What's the left-hand column and the right-hand column? Okay. Kai Ming, can you read to me what's the left-hand column and what's the right-hand column? I will try to get some of you to participate. Okay, so if I try to unmute you, you will get a box that says host wants to unmute you. So you just say yes, unmute. How about Celeste? What's the difference between the left-hand side and the right-hand side, Celeste? Celeste, not around. Doreen, how about Doreen? If none of you have a voice, then tomorrow you can't go to school. Huh? I'll write to your school to say all these children lost their voices. They can't come because they wore the mask for too long. Who wants to say? Then you can raise your hand so I can also pick volunteers. You can just raise your hand. I don't know whether you know how to use Zoom by now. You should be able to raise your hand. You should be able to type. Sri Karan, are you around? You want to say something?
Yes.
Hi, Sri.
I don't see anything.
No need to say anything. Just tell me what you see on the slide.
Oh,
Do you see some?
I see incident rays, reflected rays, and the regular reflection and diffuse reflection.
Exactly. So the left hand side is regular reflection and right hand side is diffuse reflection. That's what we're going to study now. Thank you, Sri Karan. Okay, so I just wanted you to pick up on these two words. So I'm going to point that to you here. You see the diffuse here and see the regular here. So you need to know the difference between the regular and diffuse, where regular occurs on a smooth surface, which is like the mirror we just saw, and diffuse will occur on any rough surface, which could be paper or any wood or any table. So you don't have exact equal landing of the ray. Can you see the rays coming down? On the left, all the rays come down parallel and then they hit the surface and they go off exactly same angles. Whereas here, because the surface is rough, the angles at which they come in are different and they go off at different angles. So therefore, you do not have a clear image of the light falling on your eyes. So you don't make out a reflected image. Okay, so there's no image usually of a piece of paper. That is what it is when you mean by a diffuse reflection over here. Okay, so individual rays are reflected in different direction. However, it does not mean I is not equal to R. I is still equal to R. Whenever it hits the surface, it will bounce off exactly off that surface at another angle R from the normal. Okay, if you look at all the incident angles and the reflected angles, you will see that they are actually equal. You can see I can draw a normal here, I can draw a normal here, I can draw a normal here. For this one, they are equal. Okay, what do I mean by this? We will do a question in a while and we will realize what I mean by that. Okay, so how about image form? You can see on the right, there's no image form. So we got no image to talk about. Very simple, no image form. Whereas on the left, you have an image which is virtual, laterally inverted, upright, same size, same distance from the reflected surface, which is the same characteristics that you pick up that we talked about from the mirror. So here is where the difference lies. Okay, in any question, they may ask you to draw reflected on a regular versus diffuse. They may ask you to describe the image. Okay, describe the image on the left versus on the right. On the right is very easy. Just say no image form. On the left, not so easy. You need to know more characteristics like this to be able to write. And they won't ask you like write all. We'll just say write 2, write 3. So you may have to remember just 2 or 3 for the purpose of writing it in the exams. Okay. Now, who else has a voice? Remember, just now Sri Karan didn't know what to say, but he actually knew what to say. Just with a little bit of push, he knew what to say. So listen to the question carefully, and then you will know what to say because you are not having your mind focused. You like don't even know what I asked. Okay, let me repeat the question here. The question is, what are the 3 columns here talking about? Okay, what are the 3 columns here talking about? Let's see. My favorite. Let's go back to Celeste and Kaiming. Earlier, I wanted them to come in, but they didn't. So let's see if Celeste and Kaiming this time they listened to my question or not. Now that it's all in your hands, you know. If you don't mute yourself, you cannot talk. Let me try. Doreen. Either that or unmute button doesn't work. If you don't want to say anything, it's okay also. You can just say, hi, Mr. Ali, nice to meet you. I don't want to say anything. And then I will say it for you. But at least we can say hi. Who else wants to say hi? Okay, it's not all about learning. Sometimes we can just chit chat also, no problem. That's what you do. You guys do in class, right? You all are friends with your teachers in class, am I right? So nobody interested to say anything. Yeah, I'll just pause here. No, I still don't know interested to teach you. Okay, Kaiming, your mic maybe doesn't work. Okay, it's all right. Maybe you can type, Kaiming. Kaiming, you can type. I saw you type. So Kaiming, please type to me, what are we talking about in this slide? What are the 3 columns? Just type the 3 column names. Very easy, right, Kaiming? See, after I ask the question, when I ask one of you, then you ask me to repeat the question, because all of you switch off your mind and then you don't listen to the question. You're not in the class, okay? Please, it's not very, very respectful to not be in the class if you are in the class. If you don't want to be in the class, you can leave the class, right? Am I right or not? If you are hungry, you want to eat dinner, go. I'm not stopping you. Just leave, go have dinner, have your fruit, come back about 10 minutes later. I'll still be here. I'm not locking the class. Okay. Jethro has typed to me, is saying, oh, this is 3 columns talking about plane mirror, convex mirror, and concave mirror. Charmaine has answered as well, saying 3 columns are talking about the differences of mirrors. Yes, the 3 different types of mirrors. Okay, we don't just have plane mirror. We do have convex and concave. And you know, plane mirrors are in our toilets, in our bathrooms, or same, right? In our cupboards, in our bedrooms. But convex and concave, not so much. So what are convex and concave? Convex mirrors are curved mirrors. Concave mirrors are also curved, but it depends on which way they're curving. Let's say you're standing in front of the mirror and it curves towards you. That means if you see an N shape. It's your N shape in front of you. N, you know, N? Yeah. That is a concave mirror, right? Now, when you have a convex mirror, oh, I still hear, now I hear people. Okay. When I ask you to talk, you don't want to talk. Now you want to talk when I talk. Come on, guys. You're old enough to know better. Come on. Okay. When you want, if you want to answer, no problem. You just unmute or you just raise your hand. I unmute you. You just answer, no problem. Like I said, just say hi. Say hi. The lesson is very boring. Can I go and have my dinner? That's it. Okay. And I'll say bye-bye. Thank you. All right. So the 3 columns here are plane, convex, concave. Like I said, if you stand in front of the mirror and the mirror is curving away from you, it's a U shape. Remember, it can be an N shape or a U shape mirror. These are called concave or convex. If it's an N shape, it's concave. If it's U shape, it's convex, it's curving away from you. And then you will see the image of yourself. Do you know sometimes you can look like a clown in those mirrors? Have you seen mirrors that you look like a clown? Suddenly you look so small, suddenly you look so big like a giant orang-utan. Suddenly, why? Because these are curved mirrors. Curved mirrors do something. They let the light bounce off in different directions, causing you to look smaller or bigger and so on. Okay, so plane mirror is very easy on the extreme left-hand side. Plane mirror is very easy. We know it's same size, laterally inverted upright. We have lived with mirrors all our lives for 13 years. For 14 years, we've seen mirrors. But convex mirrors, not all of us have seen. So we need to study a little bit. Like convex mirrors will cause the object to be smaller and the rest of the things are the same. Laterally inverted, upright, and all that. For concave mirror, the object will look bigger, which means if it's N shape, you will look bigger. If it's U shape, you will look smaller. That's it. Okay, that's very little minute difference that you see when the mirrors are curved. But what are the users? Okay, this is what are the users for. The users are more important than actually all the characteristics. The characteristics, the main one we want to know is which one is smaller, which one is bigger, which one is same size. Once you know that, the users, however, you can see, let's do the first column. For plane mirror, of course, to see ourselves, right? We go to the toilet, we see ourselves, we see our hair, we see our eyes, we see it exactly like it is, we comb our hair. Imagine all our toilets in the school, they change to convex. It's not going to be of any use because we cannot see ourselves clearly. We see ourselves smaller than the object, smaller than ourselves, and we're going to have trouble. So the use of the plane mirror is to see ourselves, to have a reflection, but can also be used in periscopes and to increase the amount of light. For convex mirror, to see round corners. Now, these mirrors may not be in our homes or in our toilets, but there are a lot of them on the roads because our cars need to see around the bend, a corner. Okay, so they use convex mirrors to show two sides of the road, and so you can see, and also mirrors along the staircase on double-decker buses. You know, when you're down, you can see the people upstairs, or you can see if there's space upstairs using a mirror. How many of you have been to a double-decker bus, stood down and looked up and you saw a mirror? If you saw that, nowadays advanced already. They use even cameras, they use webcam, they use videos. That means a video is actually videoing the whole upper deck, and then you can actually see. But cheaper is to use the mirror. Okay, so mirrors have double deckers have convex mirrors in the buses for wider field of vision and so on. And then where do you use concave? Now these examples are important for you to have at your fingertips to be able to write that down whenever they ask you. Where a magnified upright image is needed, example, shaving, makeup, dental mirror. When you go to a dentist, I can assure you, all of you have been to a dentist before, if not in private, but in school. Yes or no? Yes, 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 all of you have. And the dentist has to see your tiny little teeth, and has to not only see the tiny little teeth, he has to see the tiny little hole in your teeth. So he needs a mirror that not only can see your tooth, but see the hole in the tooth. So he needs to magnify it to make it bigger. So therefore, the mirror that he carries in the hand, the mirror that carries in the hand, is a concave mirror, which makes objects look bigger. So there are uses for convex and concave, and all of them are written down here. I just wish you guys will remember it, because if you don't, and they do ask you on the paper in the questions, then you're going to be able to write. They will ask you, which mirror does a dentist use? Then you straight away think, oh, dentist, my teeth is smaller, so I need to make it bigger. So use a concave. And for cars to go around bends, oh, you need to see around curves, you need to see both sides, so you have a bigger field of vision, so you need to use convex. Okay. So there you go. Now this is called a, how many of you know the name of this instrument? Type to me if you know the name. Or if you want to shout it out, you can shout it out. You raise your hand, I will call you. I'll unmute you, because no fun, you are so quiet. I want to hear other voices. You only hear Ali's voice. Okay, you want to shout out? What's the name of this instrument?
Periscope.
Very good. Periscope, right? How come suddenly one voice came out, guys? Because he raised his hand. Or she raised his hand. She raised his hand, yeah. And I called her immediately. She immediately answered. It's over. So easy. Easy question. Okay. Next one. Who want to answer later? You raise your hand. Huh? Okay, this is a periscope which works in the principle of reflection. So light ray that is red in color will hit this mirror that is placed at an angle, because of the reflection that will have the exact same value for the angle, will but bounce. Okay, another word for reflect is bounce, right? So bounce, we just normally say, our primary 3 kid will say bounce, but we don't say bounce, we say reflect. When they reflect off the surface and reach the eye, then we are able to see the object that is over on the other side. So this is my favorite example. You know, the kitchen has kitchen cabinets which are very high up. You have the lower cabinet, and then you have the high cabinet. And all the goodies and biscuits and chocolates are hid up there because you cannot reach them. Your mommy can reach. Sometimes your mommy takes the ladder to reach. It's so high up, right? So she knows you can't see what she put there unless you use a ladder. However, if you get hold of a periscope like this one, imagine you have this instrument that you have right in front of you. What will happen is the mirrors will help. It's so funny. Will help to check out all the goodies inside the cabinet above by using this principle. Can you build this on your own? Yes, you can. Go to the bookshop. Okay, just like you can buy magnets in the bookshop, you can buy mirrors too. You can buy makeup mirrors. Those of you who are girls, you know, makeup mirrors that you can keep in your wallet, just to see your face once in a while. And some boys, you do have them as well. Small mirrors, right? They are very cheap. Okay, though they were called makeup mirrors, you say, oh, I'm going to buy them for my science experiment. You stick them on angle like this. You make a cardboard. Just take your Cocoa Pops cereal box and cut it up and do a cave and stick some mirrors in like this and try to use and see what you see. And you can start looking up into items that are very high up. And therefore, when you're under the sea, in the sea, you can also see what is above the sea surface by using a periscope. And who's going to use them? Scuba divers, submariners, people in the submarine who are underwater all the time. They don't know what's going on above the sea. They want to see, they use a periscope. So you can also bring it to your swimming pool, right? And try this. So in order to bring the swimming pool and it's going to be wet, then you don't want to wet your cardboard. So you don't use cardboard then. You don't use your Cocoa Pops, Cocoa Crunch. Who likes Cocoa Pops? Who likes Cocoa Crunch? You can type to me your answer. Yeah, like I said, I love to share. I always buy Cocoa Crunch. I like Cocoa Crunch better, right? Most of us have it for breakfast. It's one of the best because they're so healthy. It's made of wheat, okay, and it's sweet and it's just amazing chocolate. Cocoa Crunch, yes, Cocoa Crunch. So all of us have Cocoa Crunch boxes. You got excited when you hear Cocoa Crunch because you do have them, but you cannot bring it to a swimming pool. So how now? You make using a plastic. Maybe you cover the Cocoa Crunch box with a lot of plastic to keep it not getting wet, from preventing it from getting wet, or just build one from scratch using plastic itself, a hard plastic. You know those glass plastics, not glass, plastics that are hard, that does not get wet in the water. You know what I'm talking about. So get hold of your material and build one if you like. Even better, bring it to school. Even better, I know your teachers are going to scold you if you start playing with it and then they're going to confiscate it. You know what's the way around that? The first person you show to should be your science teacher. And then your science teacher is going to take hold of it and introduce it to the whole class. And then the whole class is going to have fun playing with it because you made it. And then you become famous, and the science teacher doesn't want to confiscate it because you just made a scientific instrument. And that's the way it works. Whereas you guys don't know how to think. You work the other way around. You go to school, you show everyone playing and then getting rowdy, and then it starts to break, and then you start to cry, and then you start to complain, and then it gets confiscated. That's the wrong way. Okay? Or you bring something to class, you get the teacher's permission, you're going to have fun with it. Okay? I'm sure. Because everything that you bring can be educational. Even if you bring a Beyblade, who knows what's a Beyblade? Beyblade is physics. And then we had fidget spinners. Who knows what's fidget spinners? That's physics. That's science too. So you can bring all this and get the blessings of your teacher and play with it in class if only you know how to. You must first go quietly to your teacher and say, teacher, I have this Beyblade and I have this fidget spinner and I want to show the class how to use this, and maybe you're expert and then you're going to spin it on the floor. Can, as long as you're able to get the blessing of your teacher. And then your teacher himself or herself will explain the principle of the Beyblade or the fidget spinner, and then you guys just had fun and you became the hero or the heroine because you brought a fun stuff and the class was fun today. Get what I mean, right? Just simple examples, but there are many in the world. Any toy that you have at home, just bring it to class, ask your science teacher and see if you can use it. I mean, if I was in the class, I would do whatever I just said. So ask your science teacher. All right. Okay, some of you had fun listening to that story of what to do. Good. Okay, so convex mirrors look like this. Let's have a read. Okay, many of you are really tired from going to school, so I won't ask you to read. Let me read. Convex mirrors curve outwards. Okay, we know, which means what? U-shaped, and are used as side mirrors on cars. Oh, the one that in our car. Okay, it's not only on the road. You know the one in the car? It is also a convex mirror, the one that is at the side, so that we can see a wider area of the road. Okay, not only just a narrow area, but a wide area. It keeps us safe, keeps the driver safe, keeps your dad and mom safe, because we can see more things than usual by making the mirror convex. So like a plane mirror, the image is upright, lateral, inverted, and virtual. However, the image is smaller and distorted. So we see a large area. Everything becomes smaller, doesn't matter. We see the bike a bit smaller, the car a bit smaller, so that they can fit into the mirror, but we can see at least the bike and the car, both of them in the same mirror. You understand the picture? It's not to make things bigger. If you make things bigger, you'll see a big bike. You'll see a big bike on the mirror. Your mom or dad will see a big bike, and that's it. He won't even see the rider or the size of the car beside it. You know, you want to see more things, it will become smaller and you have a wider reach. So that's the idea. So I guess you know roughly what mirror there is. Now, next time you get into your car in the morning when your parents are dropping you, just ask them, Mom, do you know what mirror you have on the side mirrors? 80% of the parents would not know because they forgot. Okay, just like you, but you also forget. Even if I teach you today, tomorrow morning you forget, right? Okay, or your science teacher teaches you, always forget. So how do you expect your parents to remember concave and convex mirrors from secondary 1 and 2? That's like eons ago, right? So they may not remember. If they remember, give them a clap and say, well done, you are great. My science teacher said to give you 3 claps. But if they don't know, don't laugh at them, because then I will laugh at you next week as well, because you're going to forget as well. But you can teach them and say, I know last night I learned that the mirrors on the side view mirrors of the cars are convex, not plane, not concave. Okay, that's interesting. Take this stuff to the world outside. All right. Now, concave, where do we find them? Now you keep driving along, you may see a concave mirror. Where? Okay, concave mirrors curve inwards that are N-shaped, used for cosmetic mirrors, shaving mirrors, dentist mirrors, where they are made to look bigger. They are also used in reflecting telescopes for astronomy. When the object is close to the mirror, it will produce a virtual, magnified, and upright. All right? Okay, so these are the 2 differences for you to remember. Like I said, these notes are available. Just give me 24 to 48 hours, depending on the person who's helping me to upload this on the website. And go to my lesson, you can download these slides and get all the notes down and just save it into your computer. No problem. Okay, let's do question 1, which was supposed to be a homework, where I know most of you are lazy and don't do homework. So we have to do it here. Okay, we have 25 minutes to 7. I hope we can finish all the questions I have here for you just in time, so all of us can go have a good break. Okay, what's the actual time? This was shown on a mirror. So what is the actual time? Left become right, right become left. So therefore, you need to have what? This one, something like that, and this one, something like that, right? Erase over. Okay. Oh, I've made a mess out of it. Okay, let me erase for you. My pen is not controllable, so I'm not going to really do it. Maybe you can do it, but you know the idea. So it's on the left side. So what will be the time be? Will be 8 something, not 9 yet. 8 what? 8:40, not 3:20. 3:20 is this time. Hello, my friend. This 23 current. You said 3:20. 3:20 is the time that you will ask your kindergarten, right? Yeah. So 3:20 reflect on the other side is 8:40. So answer is C. Very good. Easy one. Reflection. Okay, now a girl stands at a distance of 4 meters in front of a plane mirror. A boy stands at a distance of 3 meters behind the girl. What's the distance from the girl of the image of the boy? Okay, so the girl is 4 meters and a boy is 3 meters behind the girl. That means the girl is 7 meters away from the mirror, right? So what's the distance from the girl of the image of the boy? Wow. This one is a bit tough. Huh? So I want you to take a piece of paper and draw. I'm also going to draw. I'm going to give exactly 60 seconds for all of you to draw and find out the answer. Okay. You may be surprised to know the answer is not the one that you actually got, because you need to be very careful with the question. Those of you who have done already, it's okay. Those of you who haven't done, please try it right now. It's funny because I'm receiving answers A, answer B, answer C, answer D. Okay, that means not easy. Whenever I see questions where students cannot pinpoint a particular answer, where all of you get it right, then it's difficult. Okay, what is the distance from the girl of the image of the boy? The image of the boy is behind the mirror, right? Yes or no? Just hang on. I'll try to do something so I can draw on the slide. So just give me 2 to 3 minutes. And those of you who have not gotten D as the answer, you have to redo. The answer is D. Okay, so I'm going to tell you the answer is D. So you got to redo if you didn't get answer D. Yay, I can write now. See. Yeah, that's what I wanted to do. Okay, so that I can draw the mirror. Okay, so I can draw the mirror. All of you, okay, right? Can see. If any problems, please tell me on the chat. So those of you who need to know the answer, you can actually start seeing the answer. So the mirror, and then you have the boy. He is 4 meters from the mirror. And then you have the girl. Right? How many meters? 3 meters from the boy. This is the question, okay? Now, what is the distance from the girl? This is the boy. Okay, this is the boy. And then the image. So image we shall draw in another color. Image of the boy will be here. Right? And the image of the girl will be here. Am I right? So this will be 4 meters. This will be 3 meters. And therefore, this is image of boy here and image of girl here. So now, how to answer? Find the distance from the girl to the image of the boy. So girl, I circle here. Image of the boy, I circle. So I need the distance, the total distance here. Question mark, question mark, question mark. 3 plus 4 plus 4. Very good. Okay, please take note. Girl stand at a distance. Oh, boy stands at a distance behind the girl. Okay, thanks. Who's this? Doreen. Thank you. We just changed it around. Okay, Mr. Ali was a bit confused because we just changed the dress. Shall we just change the dress? We just change. Okay, now this is better. I know. The question says this, right? So now the girl should wear the dress. Am I right? And therefore, here also, we change this dress and here like this. And therefore, wait. So the answer will change also, is it? Oh, is it answer also will change? Okay. Sorry, guys. My fault maybe. Let's redo then. If it's a girl stands 4 meters, so you know why? All the while I thought the boy was in front. Okay, girl is here. Boy is here. So image of girl, you need to change. Please follow. You need to change. This can happen in your exams also. Image of boy. As long as you confuse boy or girl, then finish. We're done. Now, this is not the distance they want. Good. Those of you pointed it out, you are sharp. Good. Give yourself a clap. You can even correct me. So it's good. Now, this is the correct diagram. Am I right? All okay? Okay to go on? Good. This is how we correct each other and learn, and that we know these kind of mistakes can happen. Good. Now the boy and girl change place. What is the distance from the girl to the image of the boy? Which means I cannot circle this, I cannot circle this. But maybe the answer will be the same. Okay, girl to the image of the boy. We actually circle different things, but still it is 4, 4, 3, which is 11. Oh, no wonder the answer is still the same. So what happened? Those of you who did it wrongly also end up same answer, because this one is multiple choice. Nobody found out you actually messed up. Nobody found out Ali messed up. I messed up also. But I got my answer. Okay, sorry guys for those the messing up of a boy and a girl. Okay, but I'm happy I can write also. Okay, a ray of light is reflected on the surface. This one very easy. You draw the normal here. This is the normal. And then they are asking you, what is I? What is R? It must be exactly equal because this is a plane mirror we are talking about. Therefore, it must be 20/20. Okay? That's it. Next question. Which statement is correct about diffuse? Remember, it's always on a rough surface. You will have this, you will have this. Okay, it's better to draw in a different color so you can see that, you know, things like this can happen. They don't all go in the same directions. So it all gets diffused. That means irregular. Remember, we used the word irregular right at the start. It's not regular. So you won't see image. So usually no image is formed. Is the characteristics of this. Okay. So a parallel beam will reflect as a parallel beam. No. A parallel beam will reflect as any kind of beam. So a parallel beam will come like this, 3 beams, and will hit the surface on a rough surface. What will happen? It won't go parallelly. It's not a regular surface. So it will go in different directions this way. So that is what will happen. Just to highlight to you the reflected. Okay, so A is definitely wrong. B, it occurs only in materials with high optical density. What is high optical density? What is it? Low optical density and high optical density. Low optical density, it allows light to pass through. High optical density, it does not allow light to pass through, so it will reflect. No. Actually, mirror is also high optical density, so it will not be diffuse. So this is wrong. Okay. It is able to produce a sharp virtual image. No, because usually no image is formed. So all of these are wrong statements. The final one, the angle of incidence is equal to the angle of reflection, because yes, there is always an incidence and there's always a reflection. As you can see on top, all my diagrams have rays that are dropping down, bounce off, and they go off. But they bounce off based on that place they bounce off, because if the surface here is this way and the surface here is this way, they bounce at different angles. But the angle that they bounce is always equal. So this is maybe 20/20. This is maybe 10/10. They are always equal, but they have a different angle. So only statement D is correct. Okay. Please, if you do not understand quickly within the 2 minutes that I discussed, it's always okay to revisit this lesson by downloading these slides and download or listening to me again on the past lessons tab, where you click on the website and just say play Ali's lesson again, and you just listen. And if you think only question 4 you don't understand, you want me to go through again, just repeat question 4 on the video. So simple, which you can't do to your class teacher. You can't say, teacher, I call you, can you repeat to me what we did after recess at 9:30? You can't do that, right? But here you can. You can just go back and make me speak again and again and again 100 times, because it's recorded and it's also playback by you, whichever question you want. So that's the beauty of it. So do not fret if the question you don't understand. You can always just go back to it. And you should if you don't understand, until you understand. Which diagram correctly shows the image of a plastic ruler in a plane mirror? Now, this is important. You just make sure you know that the mirror is at an angle like this. Okay. So, how will the image form? This is quite difficult. You have to think about how light reflects in the other side. Okay. So, usually, I will draw my own mirror. Okay. If you are standing here, your image will be on this side. Am I right? Exactly same distance away like this. Am I right? Am I right? So you draw one dot first. Okay. Then you draw the second dot because you want the plastic ruler to be like this. So you draw the second dot. And this dot is only this distance. So it's going to be this distance, short one. Then you draw this one. You draw this one. Maybe we use red color for this. So we can identify this dot. And then we can use a yellow color for this one. So can you see what I'm doing? So from here, I do that and I get a red color. And I go, this one is so far away, so I need to go so far away. And then I get that. So what do I do now? I can join. Ta-da! See what happened? Easy. So answer must be B or C only. Cannot be A, cannot be C. The plastic ruler will look like this in the mirror, okay, on the other side. Now you need, oh no, you need to do extra work because the word plastic, how does it appear? Does it appear like B or does it appear like what? C. How do you think? Now, it's very hard to imagine. So if it's hard to imagine, then you still write the word P here. Plastic. Okay, since you can have a line here. Okay, now this line will go and form this line here because this line is parallel to this line, parallel to the ruler. So therefore you get here. And this one is further away. So if you calculate, it is also further away. So the P is going this way, not going this way. Okay, so therefore our answer is number 5 is C or B. I didn't do a good job of drawing, but I can try L then. L, okay, L should be, since this is nearer, these two are nearer, so you get L like this. Okay, and therefore getting closer and closer to what you should be getting. Okay, so not B, but C. Okay, you can work it out by drawing even just the letter P like this. What happens is you can just do this and you have a mirror. Take out the ruler and let's just draw dots for this. Okay, so it's not easy, that's why I'm taking some time to do for you. So one dot here, and you can draw even one dot here. So this dot and this dot is most likely going to be here. So that's why you get this answer, okay, compared to the other one. Since it's further away and down, you can measure and do it slowly. Okay, in the exam you get this question, good luck to you. You need to do a bit of work by writing just one alphabet. Maybe just choose the favorite alphabet P and you can see how P will appear. Okay, do L or A or S and whatever. You can see what will appear. Okay, first you determine the ruler, then after that you determine the alphabet, and then you're done. Difficult, right? I know. Okay, this is how we give you more difficult questions in the exams. All right, now same thing. What's the distance of the visitor to the image of the coin? Okay, now this one already drawn for us, no confusion. So the image of the coin is here, image of the coin, and the girl will definitely be here. Am I right? And she is, this is how much? 0.17 meters, and from here is 0.25 meters, and therefore we can calculate the answer where they ask you what is the distance of the visitor to the image of the coin. So the visitor is here, image is here, so you just need the full length from here to here. You know what to plus now. 0.25 plus 0.17 plus 0.17. Who knows how to do this mentally? Use a calculator also can. 14, 19, 19 carry 1, 4, 5, 0.59. Answer B. Right? Okay, good. Okay, tough question. Okay, this one, I think I will have time to do question 7 with you. But question 8, I'll probably let you try it because I know many of you didn't do the homework, number 1. Number 2, once you attended the class, you feel like, oh, okay, now I learned something. Let me go and try these questions. And then you will get the answers next week. Because I don't want to go through a question so much and waste so much effort when you are not prepared. So I'd rather tell you that, hey, this lesson, these question slides will be up as usual. Go and try them. Maybe next week we will carry this forward to next week's class because these questions are not exactly easy. So I'm just going to help you along, maybe show you how to do, but the exact answer I won't reveal until next week. So that gives you some motivation to actually try it on your own. Because if you don't try, then there's no fun at all. I mean, these questions are fun, question number 1. Number 2, they actually came from exam papers, which if you do not try them, right, what happened is one day you will see them in your exam papers. And you're going to come out crying because you did not know how to do it. It's so difficult. And finally, because you didn't listen to Ali teaching this when he said, better listen and better do. So you will regret. So you don't want to regret, then better try it. Okay, now is the time to try and fail than to fail it in the exam. Okay, so try it. So this is interesting because Crystal is seated near the mirror M, as shown in figure. This is person sitting and there's a mirror. There are 4 seats. Okay, 1, 2, 3, 4 behind her. Okay, Miss Fiona and Fiona, mirror M and Fiona. Okay, so there are 2 persons. Okay, so this is Crystal. Let me circle the 2 persons' names so that you know where I'm reading. Fiona comes into the room and she's asked to sit at one of the 4 seats. 1, 2, 3, 4. This is a game. Huh? I know you like games. You like computer games. You like board games. This is a game that requires you to pick up the knowledge we learned today from 6 to 7 and answer the question. It's really a game. You don't trust me, you try it. The next week you tell me, Chir, you lied to us, it's not a game. Then I will apologize. But it is a game. So let's try the game. Okay, so Fiona is now asked to sit at one of the 4 seats just such that she can see the image of Crystal in the mirror. Fiona is asked to choose seat 1, seat 2, seat 3, or seat 4, such that she can see the image of Crystal. Of course, she can see Crystal. She can see Crystal. You sit on any seat, you can see the person Crystal. Let's say, imagine you are Fiona and you can sit on the seat. You'll see Crystal, definitely. But can you see the image of Crystal? That means her image, the image is behind the mirror. Can you see her? If you sit at 1, will you be able to see Crystal's image? If you sit at 2, will you be able to see Crystal's image? If you see at 3, will you be able to see? So first things what you need to do is to find Crystal's image. Okay, where is Crystal's image? This is the mirror. There's no mirror right here. So what will happen is Crystal's image has to touch the mirror and should be somewhere there and also should reach Fiona's eyes. Okay, so since I'm going to let you try this, I'm not going to tell you exactly how to do it, but I'm going to flash the answer quickly and then you go and figure out how to draw the diagram. Next week, I want to see the diagram. Okay, so first we state 2 properties of the image. Okay, this one very easy. Okay, any properties like virtual, same size, what else? Laterally inverted are all acceptable answers. You are only asked for two properties. This one you will get this. This got nothing to do with this. This is from textbook. Right. Okay, so you got a lot of properties. I'm flashing because I need you to do this. Now, locate the image of crystal in the mirror. Okay, that's the first thing you need to do. So I'm going to show you quickly. It has to be right across there, right there, where it's K. Here, I'm going to show you here. This is the answer. But how to draw? Now draw suitable rays to show the maximum field of view of mirror M. Now, drawing is difficult. That's why I want to discuss slowly and surely next week. I don't want to rush through it. So next week I will go through this. How to draw rays. Okay, it's going to look something like this. So complicated, but how do you draw? I cannot show you until next week. You need to know. Go figure out. After you draw that, then you can answer part D. Can you see after you answer A, B, C, then finally you come to D, and then Fiona can pick her seat. Fiona has to sit on a seat where she will be able to see the image of crystal. Where? Okay, let's flash to you quickly again. It should be like that. And there should be a seat which she chooses. 1, 2, 3, or 4. How to know? You will tell me next week. I will ask each one of you whether you chose seat 1, seat 2, seat 3, or seat 4. And then probably I'll say, hey, how do you know it's seat 4? Show me the answer. Then I'll ask you to pick up a paper and show me the answer on the screen like this. Look. Then I know you did your work. Those who didn't do their work will have nothing to show me. Then I know I catch you already on that day. Okay. Next. Okay. So we have bonus question E also. Crystal is able to see the image of Fiona only if Fiona is seated at 2 of the seats. Now, this is the other way around. Your friend is going to see you now. Just now you see your friend's image. Now your friend wants to see you. Can she see you? Maybe not. Depends on where you are seated, right? Can only see you if you are seated in 2 of the seats. So which 2 seats are those? Also, you need to be able to tell me next week. All these answers are very easy if you know how to draw that diagram. Please draw a ray diagram where the light travels from the person to the mirror and to the other person. That means from you to the friend to you, and must have mirror in between, and then you'll be done. How to do all that? Try. You don't know, refer back to your textbook, go to the light chapter, see how people draw ray diagrams. But I don't think you'll find the answer to this question anywhere, except from me next week. Okay. And if you know how to do that question, then question 8 will be of the same format, where you have 2 people standing at position A and B. One person's name is Alicia. The other person's name is Bern. So I'm going to give 8 to stand at A, and Bern starts standing at the letter B. Obviously, his name starts with B. So, and you have a shop window and you have some walls. So this shop window is the one that is going to act as the mirror. Because although it cannot show the full reflection, it can show a small little reflection. Because you stand in front of a shopping center, you actually can see a little bit of reflection. Even in the lift, in the glass of your car. It's not a mirror, but you still see the reflection. So they are going to see reflections of each other. So you're going to have a reflection, something like that. I need you to draw. Okay, so on figure 1, draw rays to show by reflection how Alicia is able to see Bern's image. You're supposed to do something like that, and then you draw arrows. Alicia is able to see Bern's image. Looks like I already draw the answer. So it's something like that. And then, hence by drawing another light ray, indicate with the letter I where the image of Bern will be. This is actually very easy. Okay, the image of Bern will be right across him. Right across him with exactly the same distance. Am I right? So it should be here. And you are labeling it with I, not B prime or your A or your own favorite, or you call it image. This is wrong, this is wrong, this is wrong. Why? Because in the question they say use the letter I, you use the letter I. If I'm the teacher, your teacher is there, they will mark you wrong for any other labeling other than what the question tells you to. That's why you'll be wrong. And then this question is interesting. Okay, Alicia moves away from Bern. She's moving. Can you see she's moving? She moves to a position Y now, a new position. Can you see? Now In the diagram, you're supposed to mark with the letter X the furthest position along AY to which Alicia can move. That means how far can she move? Can she move till here, till here, till here, or till here? 1, 2, 3, or 4. Okay. Where she can still see Burn in the shop window because Burn's image is somewhere here, isn't it? Burn. So it's somewhere here. So can she see if she moves to position 3? Cannot. Position 4 cannot. Position 2 can. Position 1 can. But which one is further? Position 2. So 1 and 2 can, but 2 is further. Therefore, we will erase everything and we say this is the furthest position she can go. We will measure, okay, and we will write down. Briefly explain how you decide. So all this is up to you to do and see next week what's the answer. So I'm not going to discuss the full answer, but I'm going to end the lesson. Okay. So today's lesson is about mirrors and reflection only. If you are not ready for reflection, next week's reflection is going to be more difficult. So that's why I say I give you 7 days. Please, please, please practice a bit of reflection. I know you are doing some other topics in school, but you will finally end up doing like 1 day, or you've already done it, then it's a revision for you. But when you do it 1 day, you will thank Ali for teaching you all these skills to be able to be the perfect student in classroom, because you'll be the one who knows all the answers. So till that day where you become the perfect student and you're getting perfect every day, because the more chapters, the more days you come to class with me, the more you're getting groomed to be the best science student that can ever be in your class. Because I'm sure not all your classmates are here, right? If not all your classmates are here, they are not enjoying this benefit that you are getting, right? And it's free, right? You didn't pay any tuition fees to me, right? So why waste it? Gain something and score higher. Instead of 70 marks, you're going to get 85 marks for your science, or even 90 for your science. And then I'll be happy. Then we can share all our science marks at the end. Deal? Good. Let's go have a rest and final day of school for this week, Friday. And then weekend comes. Okay. Thanks, Charmaine, Celeste, Jamika. All right, Doreen. See you all next week. Ta-da. Bye-bye.